All right, in this video, we're going to be taking a look at what we did in class today, the notes over solving log equations. But before I do that, let's take a look real quick at some properties that we've talked about. So what we've already learned in this class is that if you have a log, two logs that are being added together that have the same base, we can write it as the logs being multiplied together. Okay, then if we have two logs that are being subtracted, or the difference of logs that have the same base, we could write it as one log where they're being divided, okay? And then if you have for instance, like r times the log base b to the x can be written as the log of base b x to the r. So we move this number from the front and write it as the exponent, okay? Now, we also have learned that a log equation can be written as an exponential equation. So the log base b of m equals n can be written as b to the n power equals m. So b to the n equals m. We will be using what we have already learned to solve these equations. So now let's take a look at the equations, or the questions for today's assignment. All right, so number one, this simply wants you to write the log equation as an exponential equation. You do not have to solve for x. So this is a practice that we need to understand in order to solve equations. So let's do a few of these before we start solving. So log base 5 of 6 equals 2x can be written in exponential equation as this base 5 to the power of 2x equals 6. All right, number two. It's the same thing. You're asked to write this equation as an exponential equation. The difference here is that you don't see a base written. Well, we don't see a base written. That's our common log with a base of 10. So if we have a base of 10 here, we just write that as 10 to the 5x power equals 5x minus 8. All right, number three. This is our natural log of 6 equals 3x plus 5. Well, natural log is a log with a base of e. Okay, it's a log with a base of e. So if we're going to write this in exponential equation, it's e to the power of 3x plus 5. E to the 3x plus 5 equals 6. All right, and then number four, this is the last one where we're just writing it as an exponential equation. This one looks complicated, but it's the log of base x minus 7 equals 4x minus 1. Or I'm sorry, log base x minus 7 of 4x minus 1 equals 3x plus 3. Well, this x minus 7 is your base, and the exponent becomes the 3x plus 3, and then it equals the 4x minus 1, okay? So that's just taking a log and writing it as a log equation and writing it as an exponential equation. All right, now let's do some solving. So I'm going to zoom in here on number 5. And you see here that we have log base 2 of 7x plus 3 log base 2 of 3 equals 5. Now, this is the addition of logs, which we're going to write as multiplication, okay? However, before we do that, we're going to use our power rule with this 3 right here. So this 3 is actually going to become the exponent of this log. So this 3 to the third power, I just move it to the exponent. So now I have a log base 2 of 7x plus log base 2 of 3 to the third power equals 5. So right here, 3 to the third, that's 3 times 3, which is 9 times 3 is 27. So that's 27. So now our log base 2 of 7x plus log base 2 of 27 can be written as log base 2 of 7x times 27. And that has to equal 5. So now we're going to go ahead and do 7x times 27. You get 189x. So the log says the log base 2 of 190x equals 5. So now we've condensed it down to one log, and we can write it as an exponential equation in order to solve it. So this base 2 is the base 2 to the exponent, or to the fifth power, equals 189x. okay? Now I've just rewritten it over here. Actually, 2 to the 5th is 32. So now my equation says 32 equals 189x. Well, if I'm solving for x and it's being multiplied by 189, I use the inverse, which is to divide by 189, both sides. So x is going to equal 32 divided by 189. And that's already simplified, so that's actually your answer. Okay, let's move on to number 6. So we have two logs again that are being added together, okay? So we're going to be writing them as a multiplication log. So log base 5 of 3x plus 3 log base 5 of 3. Again, I'm moving this 3 as the exponent. So I have 3 to the 3rd, which again is 27. So now our log base 5 of 3x plus log base 5 of 27 equals 5. These have the same base. They're added together, so we're going to write them as 3x times 27. When you multiply 3x times 27, you get 81x. So the condensed log now reads log base 5 of 81x equals 5. Now we take this log equation and write it as an exponential equation. 5 to the 5th power equals 81x. All right, and if 5 to the 5th power is 3,125, and if that equals 81 times x, we're trying to solve for x, we divide both sides by 81, and this is your answer, 3,125 divided by 81. All right, number 7. We have log base 7 of 9x minus log base 7 of 3 equals 2. All right, so our quotient property here, if they're being subtracted, and if two logs are, if it's the difference of two logs and they have the same base, then we can write it as the division of those two logs, our quotient property. So log base 7 of 9x divided by 3. Of course, 9x divided by 3 is 3x, so I'm writing it as log base 7 of 3x equals 2. Now I've condensed it and I have a log equation that I can solve, and I solve that by writing it as an exponential equation. 7 to the power of 2, or 7 squared, equals 3x. 7 squared is 49, and 49 equals 3x, so to solve for x, we divide by 3, and 49 over 3 is your answer. All right, number 8. Again, we have these two logs, and it's the difference of those two logs. They do have the same base, so we're going to use our quotient property. We're going to divide them. So log base 7 of, or log base 2 of 7x minus 2 log base 2 of 9 equals 2. Well, this 2 right here in front of this log is going to be, we're going to use the power rule, and it becomes the exponent of this 9. And 9 squared is 81. So we could write it as log base 2 of 7x minus log base 2 of 81. And then when we condense that, we write it in as a division. So log base 2 of 7x divided by 81 equals 2. Okay, this 7x over 81 can't really be simplified. So now we have our log equation that we're going to write as an exponential equation. The base of 2 to the exponent of 2, or 2 squared, equals the 7x over 81. Well, 2 squared is 4. So now it says 4 equals 7x over 81. Okay, we're trying to solve for x. It is being multiplied by 7, but all of that is being divided by 81. So the inverse of dividing by 81 is to multiply by 81. Because this 81 and 81 would kind of cancel each other out, because 81 divided by 81 is ends up being 1. Okay, but we have to multiply the left side by 81. So 81 times 4, that's 324 equals 7x. And then we divide both sides by 7, and x equals 324 divided by 7. Okay, that was the page that we handed out in class, and then we did look at one more, so let's take a look at this one. Okay, this is actually a natural log, okay? The ln, or 6 ln of 6x plus 1 plus 10 equals negative 2. Okay, we're going to try to solve for x, okay? Now, the first thing I'm going to do with this natural log is I'm going to do the inverse of this plus 10. I'm going to subtract 10 from both sides. Okay, when I do that, we end up with 6 ln of 6x plus 1 equals negative 12. That's negative 2 minus 10. Okay, now, all of this here is being multiplied by 6. So I could do the inverse, which is to divide by 6. When I divide by 6, on the left side, I have negative 12 divided by 6, which is negative 2. And of course, over here, 6 divided by 6 is 1. So it looks like this. The 6 is here on the left side. 6 divided by 6 is 1. So it's like it canceled. So the natural log of 6x plus 1 equals, and then negative 12 divided by 6 is negative 2. All right, now, this natural log is a log with a base of e. So the base of e to the exponent negative 2 equals 6x plus 1. Now we have this exponential equation that we can solve for x. This plus 1, we're going to do the inverse, which is to subtract 1 from both sides. And then over here, e to the negative 2 minus 1, we're just going to write that out. E to the negative 2 minus 1. E to the negative 2 minus 1 equals 6x. And then to solve for x, we divide both sides by 6. So your answer is what you see here, e to the negative 2 minus 1 divided by 6. All right, and that's a look at solving log equations using the properties that we have learned in class so far.